Welcome everyone to this webinar from Think Company. This is the third in a series of webinars that we're conducting. This is we'll be talking with Brian McElaney in a few minutes about saving projects from process debt. For those of you who are joining and aren't really familiar with Think Company is an experienced design and technology consulting firm out of Philadelphia, Pennsylvania. We do all kinds of work for improving your customers and employees' experiences within the systems and the products and tools and online digital tools and services they experience in everyday life. And we've taken some of the webinar content that or some of the seminar content that we typically deliver at conferences and local community events, and we put it into a webinar format while we're all living under quarantine. This is the third in a series of webinars that we've been doing. We'll be meeting with Mac in a few minutes, but for those of you who are interested in other webinars coming up next week, on April 16th from 3 to 4 p.m., we have Sean Hickman, who is our principal of design systems. We'll be talking about understanding design systems. It's a really interesting talk that he's going to do to sort of help people understand, not just the basics of design systems, but what really sophisticated design systems can do for organizations. So it's a great, it'll be a great webinar for people who work in large organizations, want to understand a little bit more about design systems, for designers who want to learn a little bit more about how large sophisticated design systems work and can benefit their organizations. Additionally, in a couple of weeks on April 29th, Philly Chi, which is a local community organization for user experience design in the Philadelphia area, is going to be holding a webinar called So You Want to Be a Successful UX Practitioner. So we're using our webinar platform for this. We're donating time in it over to Philly Chi. And this panel is a panel of hiring managers from organizations all around the Philadelphia area, both large organizations and agency type organizations. And they're going to be talking about essentially what they're looking for when they are looking over portfolios and resumes and interviewing people in the UX field. So it's the second part of a series of So You Want To from Philly Chi. We do this every year towards the beginning of the year, just to sort of launch as one of their first talks for the year. So would love to have anyone who's interested in developing their careers in UX learn from people from Elsevier and Vanguard, Think Company, and also we have Dan Mall who runs Super Friendly. So it'd be great to have anyone come here and attend that. So without any further ado, let's get into the webinar ground rules. Just so you all know, if you haven't noticed by now, you're all muted by default. We're going to try to get the live Q&A to start sometime around 3:45. As I mentioned, we can go as long as 4:30 if folks end up staying, so we can have up to 45 minutes of Q&A. One of our webinars did go that long. In the meantime, while the webinar is going on, if you want to post questions within the Q&A feature at the bottom of your screen, that will we'll have some folks who are in there moderating and keeping track of the Q&A channel, and Mac may even be catching some of the questions that are in there. I'll monitor Q&A towards the end and choose questions that haven't been answered for Mac to answer, or he may just go rogue and pick them out of the list himself if he's not distracted by all the other stuff going on his screen. If we do select your question, we'll probably unmute you and introduce you to ask the question yourself, so you and Mac can have a conversation around the question. If you don't want to be unmuted, or if you don't have a microphone or don't want to be in that realm but still want your question answered, you can ask it anonymously. So you can post anonymous questions in the Q&A channel, and we'll ask it for you, so that won't have to be conversational. Just a warning, in case we run out of time, we may not get to all questions, although we probably will since we're going to 4:30. And we do have some folks from Think Company who are moderating in chat and Q&A, so if you have any questions for us to answer in the meantime, then we'll be keeping track of those channels over there. So without any further ado, I'd like to get to Brian McElaney. Everyone calls him Mac. Mac has led user-focused software teams from anything from medical device monitoring systems to foreign exchange trading platforms. He currently runs the technology group at Think Company. When he's not cooking, Mac cooks competitively, drinks wine professionally as a level 3 somm. He pretends that he likes parades, and he feels that brunch should be protected by law. So without any further ado, let's get over to Mac.
Hey everybody, how you doing? Sorry, share screen moved on me for a second. Yeah, thank you all for joining me today. I really appreciate it. This is a talk I've been giving for a while now, although I changed the format up a little bit. But a couple of notes on this before we go forward. First off, these are, I'm going to tell some stories today. A lot of these are stories of my time as a tech lead. So these aren't necessarily going to be, think company clients. So, kind of a caveat there. I've had the opportunity to work with a lot of and lead a lot of engineering teams for, a little over a decade now. And so a lot of these clients I'll be talking about come from that time period of my career. Second off, this is a kind of terrifying talk to give in some ways, in that I'm going to talk a lot about, ways projects that I've been on in the past went wrong. And looking at the attendee list, there are at least a couple of people in the room who were on some of these projects with me. So that's kind of fun. As we go through this, I want to make note that I'm going to use the word we and they sometimes. And oftentimes what I mean by that is me, right? I was an active participant in the decisions that were made throughout these projects. And so, I don't want to, shed any of the, responsibility for any of that. So ultimately, this is a talk about things going wrong, right? And, it's a normal thing to happen in a software project. In fact, there's a lot of data that suggests that up to 70% of all projects fail for some definition of fail, right? So about 20% of projects fail to the point where they never see the light of day. And those are kind of terrifying numbers if you're spending money to build these things. I've had kind of a unique career in that I've worked for employers who've sold my time. I've worked for employers that have sold software that I've written as a product. I've worked as an internal team member where I was a sort of like overhead in the process. And it didn't seem to matter how well funded things were or underfunded or what kinds of projects were going on. We always found ways for things to go wrong, right? And so maybe there's some cold comfort in that, but the point of this talk is to start talking about these things, like the reasons why these projects go wrong. And by naming these things, hopefully, gain some sort of power over them, right? So a lot of people talk about debt as a metaphor to talk about these things. And, there's a definition of debt, something that's owned, maybe as part of the process. And that's a pretty good metaphor, but I like to think about, consequence, more so than debt. If you jump out of an airplane, there's a consequence. You're eventually going to hit the ground. And there's a lot of risks between the plane and the ground that need to be mitigated. And in fact, it takes 20 minutes to pack a parachute, but it's only 6 minutes to get to the ground, assuming you use the parachute. So, a lot of times the risk mitigation takes longer than the actual action you're trying to take. But in software, that analogy does tend, the skydiving analogy tends to break down very quickly, because not all organizations ever plan to hit the ground, right? If you're an early stage startup, you may hope to exit before you get to the point that you actually have to worry about any sort of debt that's in the project. You may look at an MVP and say, hey, this is a temporary prototype that we may never roll out into production, or whatever the reasoning is. So that's some of the reasons why these conversations can be difficult. Others is that, there's some cultural aspects to this that come into play, right? Because everyone kind of approaches writing software and designing software differently. So some of these boundaries that we're going to kind of create are a little arbitrary. It's kind of like looking at stars in the sky, right? Is that star part of Ursa Major? Is it part of the Big Dipper? Is that the Big Dipper, or is it the Plow, or the Great Wagon, or Sapatoshi? Everybody's going to sort of like look at and have their own sort of definitions about these things. And so I'm going to come up with these terms, but these terms are kind of arbitrary. What we're trying to really get at is the concept sort of behind them, and then talk about how we can sort of like mitigate these risks in our projects. It's important to note that none of these risks or none of these debts are bad things. These debts are things that we need sometimes in order to be able to put projects out the door. And none of these things are going to be so bad that it's going to harm your project, not in any real sense. It might not be optimal, but it's not going to make your project fail. None of these things by themselves. You don't stop a train by putting a ton of pressure on one wheel. You stop a train by putting little bits of pressure on lots of wheels, and then over time, the train grinds to a halt, no matter how much it weighs, right? And tech debt and project debt work the same way. It causes friction. It slows things down, right? What we're trying to avoid is debt overhang, which is a financial services term. Basically means you've borrowed so much that you can no longer really borrow anymore. And it doesn't even matter really in the case of, financial services, whether borrowing more would be a good investment. It doesn't matter if the investment would definitely pay off. There's a point at which you've got so much debt that no one will ever lend to you again, right? And you need to start paying that debt down in order to be able to move your organization forward. I liken it to the Vietnamese telecom system. That was the icon for this webinar. But this jumbled mass of wires, it's functional. It works, right? And this services telephones in the neighborhood that it sits inside of, and it works great up until there's a problem. And when there's a problem, it's fixable, right? But it's going to take longer to crawl through all those wires and figure out which one you need to deal with in order to fix that problem, right? And that's kind of the issue that we're running into here. With all these debts, it's how do we prevent these things from slowing us down, from preventing change, from making reacting to the current reality harder. So the one I think we talk about most often in this industry is tech debt. It's a term I think probably everyone that's on this list has heard before. And this is a picture of a Cray XMP-24. This is a supercomputer. This one's turned into a bench. It sits in a museum someplace. But these were a big deal back in the 80s and early 90s. This particular one retired in 1993. But it's worth knowing that while they retired the machine, they probably did not retire the code. The COBOL applications and whatever else they had on there that ran on this particular machine were most likely moved to a new hardware architecture. In fact, a lot of these old supercomputer applications written in COBOL still run in Microsoft Azure and other cloud platforms today. And we're actually seeing that in the news right now. The current pandemic, a lot of healthcare applications and systems that are based on these old mainframe applications, even though they don't exist in the old server architecture, are still out there. And it made sense not to change them. Like, that's an important point, right? The reason you don't want to change them is because you don't necessarily understand how they work. They were very complicated pieces of software. It's hard to know whether or not, a given quirk of the system was a feature or a bug, or whether someone had workarounds that depended on that issue continuing to exist. If you fix it, you don't know what else you're going to have going on. So there's a lot of fear about breaking processes by changing these systems. But again, it's tech debt. It causes friction. The thing worked fine up until it didn't. And now some of these organizations are running into situations where they need to make changes very quickly. And they've got that Vietnamese telephone, nest of wires, sitting in the software. And they're having to take time in order to figure out how to pull these things apart. Now, it doesn't always go that way. My favorite tech debt story was from Komodo. It's a motorcycle parts retailer located down in the Navy Yard. Revzilla is their local brand for that. And it's actually the only company I'm going to name today because this is a good story, right? But when I was working there, we acquired a sister company, Cycle Gear, and they were on an old enterprise e-commerce system. And we realized that it's going to take way too long in order to make this enterprise commerce system work for the way our organization, worked most efficiently. And so we decided we're going to build a new commerce system from scratch for the sister company. We decided on Elixir. We set a deadline. None of us knew the language. None of us really had done functional programming, but we were really confident that was going to be like the future for tech. We signed a 3-month or so, whatever it was, long project in order to build out the software, and the team, buckled down and got it done. But we had a lot of problems that came up through that time period. I personally ended up sick, ended up in the hospital. And so I missed a big chunk of that release. The person that they hired to fill me in didn't have as much e-commerce experience as I did. One of the other major tech leads in the company quit, went on to another job. All this stuff kept coming up, and we, kept marching through it, kept getting feature complete, kept putting code into production. Finally, we got about 2 weeks before the day we were supposed to launch, and had my one-on-one with the CTO, and he asked me, hey, what do you think? And I said, this is a horrible idea. This is the giant rat's nest of tech debt. Like, we're going to have too many bugs. We can't launch. So he stopped me and he started asking me some questions about that. He asked, the security problems. And I said, no, not that I know of. And he said, well, are there performance problems, any leaky, abstractions or anything like that we have to worry about? I said, well, no, it's just, we don't know where all the bugs are. And he said, all right, that's just tech debt. It's going to be fine. Launch, and then we'll deal with it on the other side. And so I knowingly put into production the largest ball of tech debt I'd ever seen. But here's the thing, he was right and I was wrong, right? By putting out this new system, our improved conversion rates almost doubled revenue month over month. from the year previous. That massive revenue increase paid to increase the size of the development team. And what he was able to see and that I couldn't was all that additional money could be reinvested into the project. He was able to see that we could get a much larger team to spend the time it took to get it right, rather than having a much smaller team, continue to sort of like eke our way into never really getting to a point where things were going to work properly. And so, in a very real way, he was able to leverage the debt, leverage the fact that, this thing was suboptimal in some ways to get us to a point where we could get what we really wanted, which is a phenomenal commerce platform to run the business on. Now, the risks were there the day we launched, right? And the fear is that you don't necessarily know what all of the risks are, right? We don't know whether or not, the increase in revenue is going to cause such a massive wave of users that it did end up being crippling, which it didn't, but it could have been, right? When you pick a technology, you don't know if there's going to be available updates for, the tech that you're using long-term. There's a lot of unknown unknowns, And so, these things need to be kind of mitigated in order to make sure that they work out properly. But, in this case, it worked out great. And that was a lesson, right? That for me anyway, that these debts aren't always necessarily bad. Sometimes it's just what's necessary to get into production. So some ways we made sure that these things were mitigated. First off, isolating complexity. We had a lot of things that we knew were very complex pieces of business logic around things like shipping and those kinds of things. And so we made sure that in our code, we put those things into sort of isolated contexts and, had very clean APIs in there. But once you got to the other side of that API, it was messy, right? And it was okay because we were able to sort of deal with those things piecemeal sort of after the fact. We worked with test suites, automated user acceptance testing and unit tests in order to make sure that it was as explicit as possible how things were currently working. Give us some level of warm fuzzy that things were working, but also call out where there were areas of code that maybe weren't as fluid as we'd like them to be. Tracking churn and complexity are two big things. I'm a big fan of there's static analysis tools you can get to look at these things for a lot of languages. Recently heard Ernesto Tag Worker, local Ruby developer here in Philadelphia, talk about Skunk. It's an application he uses to assess Ruby applications. I actually did a great post, Breaking Up the Behemoth by Sandy Metz. I'll include the link to that in the webinar notes. But these things are designed to basically take a look at all of your code and say which files are changing most often. What has the highest churn, and which files have the most complexity, which things are very complex, and where you have very complex and high churn files, we want to make sure we focus our efforts on fixing those and refactoring those. Just because something's complex doesn't necessarily mean that you're going to have to deal with that tech debt, as quickly as you would something that's going to change more often. And finally, a big one, especially for startups, is socio-technical architecture. There's some great resources on that. I'll include some links to some posts by this guy, Nick Toon. But the idea behind socio-technical architecture is that when you first start out, Conway's law says that your application will be shaped basically the same way as your organization. Well, if your organization grows and starts to change and gets more complex, if your architecture doesn't grow the same way, then you're going to eventually have friction there. You need to figure out how to work those things out. And so companies like ours can come in and take a look at that situation and help organizations handle decide whether or not to reorganize themselves, reorganize the teams, or whether or not to re-architect the solution in order to make sure that things are able to move more smoothly. All right, so moving on. Next that we're going to talk about is coordination debt. It's trading clarity for communication for speed. I think with coordination, I'm a big fan of dragon boating. We do that here at Think Company, and it's a great analogy for what we're talking about here, because in dragon boating, it's I think it's 20 paddlers, all paddling at the same time. And as long as everyone gets in the rhythm, everyone's hitting the water at the same time with their paddle. It doesn't really matter. I mean, it matters, but it doesn't matter as much how fast the paddles are going. If they're in unison, the boat's going to move, and the boat will eventually start to move quickly, right? But if two of those paddlers start to row at a different rate, even if they're paddling faster than everybody else, the boat's going to start to slow down, right? Everyone's sort of moving together starts to matter. So the story here, it was one of the largest reinsurance companies. So an insurance company that insures other insurance companies. And they had this BI platform that they wanted us to build out to look at risk. How much money could they lose on a single day? We had 6 separate teams working in parallel. There was a data viz team, 2 application tier teams. There was a data science team, another separate, team working just on data cubes. There was a SharePoint team. I guess that counts as software. And so all these teams were sort of like working together. Project management came to us and said, hey, my team, the data visualization team, we're not going to be dealing with that for a while. So why don't you all take 6 months off and come back at the end of the summer? And we said, sure. So we went off, took our 6 months, came back to the project. And I remember I walked into their offices in Milwaukee, and they said, one of the developers walked up to me and asked me if I'd look at his resume for him on the side. And I was like, oh, it's a bad sign. I wonder what's going on here. And so, started looking into trying to find out, like, all right, so what should I be panicked about? And after a day of like asking questions, I was finally able to find out that everyone knew about a problem. It was that wind risk specifically wasn't handled by anybody, right? They had this like t-shirt size idea. Like if you had a very tall building, then you'd have a higher wind risk. But the idea of a tall building is very different at, say, Market and 13th and Market than it would be at 13th and like Oregon, right? Because much taller buildings over there. So tall down here might be like 5 or 6 stories, whereas tall in Center City is, maybe 30 or 40. So, because the issue wasn't that people missed this requirement, that was going to be a problem. It's that each team decided it was going to be somebody else's problem. Each team decided that, the data science team was like, oh, it's fine. The data cubes will handle it. Data cubes were like, data science will handle it. The application team was like, oh, it's okay. They'll handle it on the front end. Everybody knew it was there, but everyone sort of like kept punting it until it kind of got to my team. And at that point, there wasn't much we could do. It caused a massive rewrite of a lot of code across multiple teams. Set the project back 4 months, and they ended up running out of budget. That particular project ended, and then they ended up kicking off another one a little later on. Here's the thing. It's not that parallel doesn't work, right? You can have teams work in parallel and be isolated and get a lot of things done. But if you do, you need to have a real strong PMO sitting in the middle of that, managing that project. And it's kind of like a conductor in an orchestra, slowing up teams and speeding them up, slowing them down, making sure people are sort of on the same page, making sure that there's a shared vision for what we're all trying to accomplish. The issue wasn't in, the contract, right? The issue was that the requirements are being read differently. And, we'll cover this again in a second, but, everyone was under pressure throughout all of that, right? Everyone had prestige. They wanted the client, the stakeholder to believe that we were, good at our jobs as a vendor. We had budget concerns. If we had to deal with the problem and somebody else didn't, then that would make us make less money. We had conflicting goals, between the different organizations. And, all those pressures are real, and all of them prevent us from being able to work together naturally without something kind of sitting in the middle of all these different efforts, making sure that we all eventually get on the same page. One of the major risks with that is that in that situation, because I had that pressure and I'm worried about my prestige and my budget, I have a tendency to say that things are okay when they're not. We jokingly refer to this sometimes as the watermelon effect. It's green on the outside, but if you start to like really peel it apart, it turns out it's red on the inside. So getting past this is about getting in sync. It's like a good improv troupe, right? Everyone sort of needs to be able to riff off of each other, and you're able to do that because you've got a shared understanding of how each other works. So one way to get there is to have visual feature documentation. I'm not a huge fan of prose. If you're writing out features long form by hand, you might end up with cultural differences. If you're working across, international teams and those kinds of things, you might have people who have a different definition for a given word or a misunderstanding about what they read, but think that they know what they're looking at. Secondly, iterative prototypes, even better than having something visual is having something you can click on, right? And it's nice if those things can sort of like highlight a specific thing and then slowly kind of get more complex over time. Actually, I'm working on a system right now where one of the first things we did was make sure that we could copy a few dozen cells from Excel, and then paste those into an application in a web browser. We know it's possible, but we want to make sure we were able to show how that works and make sure that everyone around the teams were able to look at that feature and say, yep, that's how we think that should work. Or, did we need to like tweak the workflow a little bit in order to make sure that everyone was kind of on board? Well-documented APIs are huge. And when I say application programming interfaces, some of that's code. I think it's also, when I say APIs, it's sort of a coder shorthand for the way we communicate, right? Making sure that teams have a well-defined understanding of how they're going to communicate to each other. Are we going to include risk registers? Are we going to, have everybody show up for the agile ceremonies and those kinds of things? An understanding of how these things work at the beginning of a project really help out. And then finally, North Star design, right? It's important that I believe in agile. I believe in, working through MVPs and those sorts of things. And at the beginning, it doesn't maybe make as much sense to design something that's not going to happen for a few years. But it's important at some point in the process, the closer you get to the ground, if you're jumping out of the airplane, you need to start thinking about taking the time to figure out like what that direction is. And that theme is going to come back again here in a little bit. All right, next up is going to be context debt. It's a little different from the last one in that, this is kind of more individual to individual than team to team. But it's when people tend to understand the what, but they don't necessarily understand the why, right? This particular picture is pretty tranquil. If I put you on a beach and asked you to replicate this picture, I'm sure you'd be able to conceive of how you might be able to take that picture. You're standing there with me at the same time. But what you don't see in the picture is I'm actually neck deep in shark infested waters when I took this picture. Taking this picture was a remarkably dumb idea. And somebody probably should have stopped me from taking the picture. I just didn't ask. I was moving faster than the speed of good ideas in that. So I want to talk a bit about the idea of a 10x engineer. This one's kind of beat to death. But there's a great concept from Jess Kerr. This is another talk I'll post in the webinar notes. Where she talked about how the problem with a 10x engineer is not that they necessarily move fast. It's that they're able to change context faster than the other developers around them are able to keep up, right? So I was working with this product company once, and we had a 10x engineer, phenomenal developer, really, really, really prolific. Could go away for a couple of weeks, come back with 30% of the application built. But this application was a platform, right? And so lots of other developers were leveraging this platform to implement individual applications on top of the platform. And so this 10x engineer was able to go in there and change how that platform worked really fast. And then all these other developers who were extremely competent would have to learn this new context, this new way of working, and change all of their code, right? This became problematic over time, and we ended up losing a lot of money. And so even though this one individual was moving really fast, the team itself had a lot of issues keeping up with that one individual, which ended up slowing the overall effort down quite a bit, especially when you started talking about juniors. And because we couldn't use juniors, making changes to the system became more and more expensive too. And so while we were able to have a real high rate of utilization for one person, overall, it wasn't as efficient as it might have been otherwise. So here's the thing, fast is great. Every race has got an anchor. I get that, and you've got that one person you sort of hand things off to. But without having that ability to, keep the rest of the team in motion, make sure the rest of the team is able to move fast around the track, these things can sort of like break down very quickly. And what you find is that over time, accepting those anti-patterns, accepting that this person's able to change the context and just letting them go with it, leads to other problems, right? Before long, this person's able to move so fast, you don't want to slow them down anymore. You become dependent on their performance. And so you start trying to exempt them from code reviews or stop questioning their architectural ideas. Over time, this person starts to realize sometimes that they're that important. And many times you end up with having a lot of like bad behavior. I don't feel like showing up at the meetings anymore. I don't want to communicate anymore. I don't feel like I should have to answer to this person or work with that person. And it becomes problematic again, not because that individual by themselves is going to bring the project down. It's that it's adding more friction to a process that already exists. And that friction, in this case, makes it really hard to understand what's going on, right? Because if that person's changing the context, everything you've scoped, everything you've estimated up to that point starts to evaporate. Those estimates no longer count. Those are going to become longer. People are going to have to go in there and investigate how the system's architected and add that to the time that it's going to take to get things done. So you end up with this idea of shortening your scope, this idea that no one really knows what the actual cost is going to be until long after the work is done. Right? So mitigating this is focusing on the simple, focusing on the repeatable. right? Use your code reviews as a way to educate developers. If you're a 10x engineer, right, or if you have a 10x engineer, you want a culture where those code reviews are less about trying to find defects and more about teaching architecture to other developers. And that lets you be fast, lets you be prolific. But then if you are going through the code review process and teaching everyone the architecture of these systems as you're moving fast, they're able then to keep up with that context shift, and suddenly the entire team is able to move faster. Value simplicity. I love this picture because this little kid showed up during a daily commute, chained the bike to the bike rack alongside of the parent, and went to wherever they went. And I love this, that process was able to be repeated by, this small person who was able to ride that bike. Another great way to do this is with design systems, and we'll see a lot more about that with the webinar next week, and this will come up a few times. But using design systems in order to make sure that these patterns start to be codified, right, a little bit. Taking the time to have your corporate governance and slowing down and saying this is how we're going to handle these kinds of components, and then trying to make those patterns repeat across the project. And that's not just design systems; that's really design patterns in general, making sure that architecture sort of stays the same throughout the application. So our next debt is morale debt, risking emotional safety in the name of shipping. Look, imposter syndrome is real. Overcoming it often involves some unhealthy decisions, right? Because we feel this sort of like lack in ourselves. We want to find ways that we can sort of like get past it, because we want our teams to succeed. We want to be praised for our work. We want job security, right? We don't want anyone to know we're a fraud. And that fear starts to like get into your head, and you start doing things that seem like a good idea at the time, but oftentimes might not pan out the way you want. So I'm working on this environmental reporting app, real sophisticated content governance. And we weren't entirely sure that the features that this company was asking for were really possible to pull off. And so we started looking into it and started hiring outside contractors and looked at it. We realized, we think it's possible, but not nearly for the amount of time that we have, not for the amount of budget we have. And so we sat down with management, and we decided as a team, all of us, it was probably, I think, 6 developers, maybe it was 4, whatever. We all sat down and we said, all right, you know what, we're going to buckle down. We're going to pull this off. 10 weeks of overtime. We really pushed hard. And in the end, we ended up succeeding, right? We ended up actually getting the feature out. The project ended up failing for completely different reasons, but we spent those 10 weeks of overtime. We looked at a thing we weren't entirely sure was possible, and we pulled it off anyway. Right? That can be okay, right? If you've got buy-in from the engineers around you to work, extra hard like that, you can go through a period where you're doing a wind sprint instead of a sprint. Right? But you don't wind sprint a triathlon. At some point, you need to slow that pace down, right? We work in an industry that requires that extra oomph sometimes. But at the same time, we have to make sure that when we have a team that works a little harder like that, we can't do that over and over and over again on a long, run like that. The problem in this case wasn't that somebody asked for the effort. The problem is that by the time we realized that we were burning out, we didn't know to stop. Right? That's because as we were pushing, we kept succeeding. And every time we succeeded, we were thanked. We celebrated. We thought it was great. Management was bragging about our dedication. We bragged about our win in public. We wrote blog articles and talked at meetups and whatnot. But an entire high-performing team burnt out at the same time. And that became problematic because if we were all burnt out, we started missing every deadline for the next 6 or 7 months. That happens because of hope creep. Right? This idea that, I'm coming from behind. I need to make up ground. So I'm going to be aspirational. Those aspirational estimates, this aspirational thinking is going to hide the true cost of an effort. I start to say, I think I can get that feature done in 3 points instead of here is how I know I can get that feature done in 3 points. We convince ourselves that things can go fast. We convince others that things can go fast. But if we're burnt out, especially, they're not going to go fast. And so this all starts to break down very quickly. Tasks start to take longer. Suddenly we're in panic-driven development. Everything is just, we have to figure out how to get this done. And this is the thing, this situation, it doesn't always come from overwork, right? Sometimes this is long-running tasks. You can put out a developer on a task that runs across like 2 or 3 sprints, they're going to burn out. Sometimes it's a sustained lack of definition, constantly working in this bubble of not knowing what it is you're trying to pull off. Sometimes it has nothing to do with work, family situations and whatever else. This is not necessarily just about, being kind to people. This is about money. right? If you have individuals or teams that are burning out, you need to take steps to mitigate that risk. Otherwise, it's going to cost your company money. So how do we do that? A big one is plan more granularly, right? This idea that a task could run across multiple sprints is super dangerous. I like the rule, don't let anything last longer than 4 hours. But the reason why you want those small pieces is because you want to be able to see velocity, right? You want to be able to see that somebody's moving faster or slower than you thought in much smaller increments, 2 to 4 hours. It's good for the person because you start to feel the velocity. If you're burnt out, saying I got done 4 tickets today because they were 2 hours each is going to feel a lot better than I got 1 ticket done was giant over the course of 2 weeks, right? Even if the effort overall is the same. Second thing is to get rid of the isolation, get people programming together, right? Pair and mob programming is a great way to start breaking down that burnout, because it starts to slow down panic-driven development. You're a little less worried about your personal how people are viewing you personally if you're working alongside somebody else, and like there's like that validation that, oh, this might be hard, right? Third, if you've got a sprint that needs that extra oomph, moves a little faster, plan to reduce your velocity for a little while. Make sure that every sprint or every other sprint you've got one that slows down, or bake refactoring time into your sprints. So your last couple of days are just spent tackling tech debt instead of trying to like push for more stuff. And finally, ship more often. Continual integration, continual deployment. These things are huge. And I find that for me personally, as an engineering manager, I've never ran into somebody who was burnt out where shipping code fast and feeling that velocity again didn't start to get that person back on an even keel. Empathy debt is next. This is actually the debt that started the talk. When I first started conceiving of this talk, this guy, a friend of mine, started talking about problems in software. I said empathy debt, and that became this talk. But empathy debt is this tendency for teams to think of real world users as stress cases instead of thinking of workflows as stress cases. It's a natural tendency, I think. I think there's a tendency for developers to think of the user as the other. And that's a dangerous place to be. Any roadmap for software that's leading away from your users is going to the wrong place. There's no fixing that. The user is the reason for the software, unless you're one of the people writing code for a processor that there's no user interface for. There's a difference between instruction and mentorship. There's a difference between guidance and empathy. And this empathy piece is real important in software because software at the end of the day is a business. I had this regional transportation company I was working with years ago, and the project that they handed me was essentially trying to find out how to train their users, their riders, on how to read timetables, right? They wanted to get people to know like what number each individual bus was throughout the day, or how to read these really complex train schedules. And we were able to sit down with the stakeholders on that and say like, hey, that's not really what you should be doing. And we did some user research and came back and those kinds of things. But we sort of find out that while the stakeholders were able to wrap their heads around that, because we were able to say like, hey, there's this little plastic box and people very soon are going to be able to like hit a button and then a car is going to drive up and take them wherever they want. Like if your public transportation is hard to use, then that's going to become problematic from a competitive standpoint. The stakeholders were able to figure that out, but the engineering team wasn't. The engineering team had a hard time breaking past that idea. For nothing, the engineering team was heavily invested in the idea that these systems were going to continue to work the way that they always worked. And so it caused a lot of problems, right? And we weren't able to produce this new application that was going to be more competitive or better for the competitive environment because the engineering team was holding us back. Now, I get it. You can't do everything. You've got to find some way to limit scope. And as engineers, we need to figure out how to limit down the infinite possibilities that are out there and make it so that we're able to ship software that does something, provides some value, even if it's not all of the value we want. But all the members of the team need to be able to see, all the members of your team need to be able to see their work through the eyes of their users. A while back ago, I was learning Spanish, and while sitting on a crowded commuter train in the morning, I had to scream into my phone, "I'm a little girl and I drink milk," because that was just what I had to do in order to get past the screen. And while that was kind of funny, maybe at the time, it was embarrassing, but now it's funny. that context was important, right? It caused me some embarrassment. But it's not always that light, we'll never sell this overseas. That's been a lie almost every time someone said that to me as an architect. Hey, that easy to understand autoplay video is going to be great, but what if it causes seizures for some users? Accessibility is a part of this. They'll just learn it. Don't worry about it. We'll just train the users. Those people aren't our customer. We don't have to worry about them. These things all are going to cause friction, and you get to the point where you're looking to change your application, you're going to have to find some way to slow it down. So an easy way to fix this is to look at having your developers take part in your user research process, right? First off, build diverse teams. There's a guy, Aaron Aldrich from Elasticsearch, had said, made a great comment at a conference a while back that diverse teams take longer to form consensus, but those decisions that they make tend to stand the test of time. They catch more blind spots. So these diverse teams will help you to see where these lack of context or these shortcuts that you're taking might in your user experience might in fact slow things down and make things harder to implement long term. Second, your validation shouldn't stop at design time. Validate with quant after you've launched. Once you see the numbers, make sure that the numbers are what you think they are. You could say that umbrellas cause rain because you've always seen umbrellas when it's raining, but that's not correlation, not causation. Right? We say the same thing when it comes to using quant to assess applications. And finally, when you're doing UX research, get your developers involved. There's something pretty impactful about a developer seeing something they worked really hard on and are personally invested in, and watching a user, not be able to figure out how to use your form or your cool widget or whatever it is. Again, pings that desire to do well, pings at your social anxiety a little bit, but will also help generate a lot of empathy for your users, so the people trying to use your application. Next is going to be UX debt, user experience debt. Back in 2017, the USS John McCain, which is not pictured, I never saw the John McCain, that's the US Gonzales. But the USS John McCain was sailing the Pacific and started to veer to the left. And this was problematic because it had a new touchscreen interface to use to drive the boat. Everyone freaked out. Everyone tried to figure out what was going on. They started running through the processes to get the thing to stop veering to the left, but they weren't able to stop the ship, and the ship ended up ramming into another boat. Unfortunately, 10 sailors died. But when the National Transportation Safety Board reviewed that crash, one of the things they said was that the interfaces did not malfunction. Right? There was nothing wrong with the interface. The software performed as it was supposed to. But at the same time, they also acknowledged that the design of that application, even though it didn't malfunction, made it really hard for people to understand how to correct a problem that existed, a real world problem. And so in a very real way, user experience is what caused that crash, right? Now they said, we need to be able to, it wasn't enough training, it wasn't enough this, it wasn't enough that. And that's to a certain extent kind of valid, right? Used to work in a lot of financial trading platforms, and those things are complex, right? You're not going to be able to make everything work super easy, in something as complex as that. But when that happens, it needs to be a system where you can require mastery, where you're using these features over and over and over again, and you can start to build that muscle memory. And then as a design team, making sure you don't change that muscle memory any more often than you have to, unless it's going to make things much easier. You can also have very sophisticated change management techniques, making sure that as you're rolling changes out, you can make sure that people are trained properly in those kinds of things. And also recognizing that not all features are mission critical, and things that aren't as mission critical, maybe they could take a little longer to complete, or maybe have a less sophisticated user experience. But on the flip side, we're only human. Right? There's a limit to our cognitive ability. There's a limit to our ability to, think about things. And we don't necessarily know that mental exhaustion is coming from using the application, coming from work, or coming from someplace else. And so these things are mission critical, especially we start talking about things like, healthcare and financial services. Making sure things are simple enough for your users to be able to figure out becomes very important. So when you're going through and you're looking at these systems, I recommend highly focusing on the 20%. Focus on the 20% of your applications that is truly different from platform to platform. If I was going to design a new motorcycle, I'm not going to start from scratch. I'm going to look at why my requirements are different than the myriad of motorcycles that are out there, and figure out how to take from what's existing to bring something new, and then design that 20% of the bike that does need to be truly different. Design systems are huge for this. But even if you're using a design system, even if you're doing heuristics, remember that all software is eventually user tested, right? Everything ends up in front of a user eventually. You want to make sure that you're doing the kind of user testing that you can still change things, in the event that you find a weakness in your system. So validate your designs. Make sure you're getting these things in front of live users and see how they react to things. And again, make sure that your developers are part of that process. All right, our last one we're going to cover is going to be orientation debt. This is a problem where you've got a plan, but you don't necessarily have a goal. And this is it comes up a lot in cases where people are talking about being agile without actually having an agile process. What do I mean by that? I was working with this company a while back ago. It was a healthcare product company. If you've ever dealt with a healthcare product, you know that these things are multi-year events. It takes 6 or 7 years to, from concept to prototyping to getting all the authorizations and FDA, mid-legal review, all this stuff. It takes a long time to get through that whole process. And the problem this company had was that they were super agile and that they kept wanting to build an MVP and do the smallest bit possible at every step of the thing. But over the course of a 7-year project, the industry changed a lot, right? So every time the industry would change, they would change their approach and start changing the way that they were looking at their software. And over time, they had a drift. Their goals kept changing over time. As every time they started up another MVP, the goal, the thing they were moving to, started to shift along with it. Without an overall strategy to drive where they were going, it made it really hard to have software that was actually going to be impactful. And it kept resetting the clock. They had to keep going back and getting reauthorized for things, sort of over and over. They were rudderless. I liken it to building a building. If you are going to build a building from a marketing perspective, there's a seductive appeal to the idea that you need to know how you're going to lay out all the rooms first. It's the most important thing. You need to make sure that we know what we're selling to people who are going to be living in this building or working in this building. But I don't know if you can see in this image, those windows don't line up. You want to outline the outside of the building, know where all the windows are going to go before you start trying to measure out the inside, because the outside is going to be much harder to change, right? And that's kind of the point here, is that the problem with this MVP, this sort of drift that happens with orientation debt, isn't necessarily that you're being experimental or being flexible, those kinds of things. It becomes problematic if you don't have that overall strategy that lets you know like where you need to go. And that strategy needs to be kind of grounded in decisions that are harder to change, right? We need to make the hard decisions up front so we understand what's going on. And those hard decisions are almost never like, what's your ERD, right? I feel like a lot of times junior developers tend to look at a new software platform and say, oh, here's how I'm going to design the database for that, long before they start thinking through what are the workflows that are going to be in that application. It's okay to cut those corners though, right? It's okay to, look at a situation and say, you know what, I'm going to get the outside of this right and the inside is going to be, suboptimal. This is an example design or of a process debt here. This window is square instead of a round hole, but it's not going to be as hard to swap out that square interior window as it would be to try to build that round exterior window into the brick after the fact. We made the hard decision first, and then the easier to change thing sort of sits behind it. So again, mitigating this, you want to tackle your biggest risks first, right? The workflows are almost always going to be your biggest risks. I can't tell you how many times in a scoping situation, someone starts trying to ask me about a very technical part of the application, and my response is, it doesn't matter. Like, what are the users going to be doing? That's the part we need to try to figure out first. Continuous refactor, making sure that, as you're, building the application, you're taking the time to adjust things over time, but make sure that that continuous refactor is going somewhere. You don't want to create a pattern, for a new thing until you've seen 3 or 4 different instances of that thing. And then you can start to find a pattern that kind of makes sense. I'll post a link from Sandy Metz. Any talk that she has on refactoring will be a great read on that sort of thing. And finally, defer your hard to change decisions. Again, to that database example, you don't even know if you need a database when you first start. Don't try to figure out the database first. Focus on those things that are going to be harder to sort of hit. All right, so wrapping up, I love this building, and this building exemplifies a lot of things that we've talked about today. They said, we don't have the funding or the time or the resources to put the entire boat into a building. So let's just put most of the boat into the building. But let's make sure that this is flexible enough of a material, just glass and some bits of metal, that if we wanted to make a building big enough to contain the entire boat, we could, right? And the parts of this thing that needed to have more time focused on it, like that foundation, it's there, right? That's solid. It's not going to change. It's great. But this upper building, lets us sort of experiment a little bit with what's going on and get to the point where we're able to know, like, hey, is this worth spending more money on, or is this, something that we need to start slowing down and being a bit more purposeful? Anyway, so I want to open up the floor to questions. I see there's at least one in the Q&A. Phil, I don't know if this is the part where you take back control. Do I need to let go?
I mean, we can leave it on questions for now if you want. I actually, before we get to this question, which I'm going to have to ask you anyway, I always learn something when I listen to you doing this talk, and the term continuous refactor like just jumped out at me. I don't know if that's been in previous versions of your talk, if that's new and I just wasn't paying attention, but I'm curious, like, can you talk to me about what that is, like what that concept is? Because I've never heard that term before, and it scares me, honestly.
Sure. So it's sort of a close analogy to that. In the development community, we say red-green refactor, right? With a test-driven development methodology, you would write a test, you would see that it fails, you would write some code that makes it pass, and then you would refactor that code to make sure that it works well, right? And so it's this idea that I'm going to do what it takes in order to get a feature to be feature complete, but then I'm going to take a step back and then do what's necessary to make sure that that system is as maintainable as possible, right? That's in the small. In the large, when I'm working through, as a tech lead on projects, I always try to make sure that every sprint has a few days of refactor baked into the process. Things go well, go according to plan. Those last 2 days of every sprint should be spent just refactoring the code that we wrote over the course of the last 2 weeks. And that's really just an acknowledgement of the idea that, no matter how good our code is, there's always, opportunity to make things more maintainable, to make sure that things, have a higher quality. And if we bake that into the process, be very mindful about it, we can save ourselves a lot of pain later on.
Great. That's helpful. Okay, I'm going to go to one question that was asked by someone, and they asked it anonymously, so I can't hand the control over to them. But I think this is actually a very timely question for the world that we are all in right now in under quarantine. So this attendee asks, you mentioned pair and mod programming, which sounds great for all the reasons that you mentioned. But these days, pair and mod programming could replace the in-person collaboration that we aren't doing right now. So do you have any tactics or suggestions on how to do pair and mod programming when both developers aren't in the same room?
Yeah, so I feel like from the mod programming side of that question is pretty easy to answer, in that it's probably easier now, in that our main way of interacting would be through a system like this. And so with mod programming, there's one person driving, and then there's an entire crowd of people that are sort of like suggesting changes. You can have a conversation across something like Zoom, and that becomes just sort of a natural way of doing it. And in fact, when I was doing a lot of mod programming in the past, we were doing that over top of chat programs much like this. But from a pair programming thing, there's a lot of applications that we can use. I'll add some links to things, but this ability to RDP into a remote system and kind of spin things up, makes it pretty easy to set up an environment where more than one person can sort of like get into the same machine and make changes at the same time, and then again connect over something like Zoom in order to make those changes. John Young looks like he's on the call, and I know he's actually working almost exclusively in a setup like that, just personally, right? But the ability to extend that out so that more than one person was like hitting the same instance, would be pretty easy. John, is there any chance that we could get you to do that workshop of yours at some point?
Absolutely. Can you hear me, Mac?
Yes. Yeah.
Yeah, for sure. Because I think what we've experimented with at Think is really two things. One is just using tools so that both developers can see the same screen and two people can collaborate. But also it's kind of part of our value chain of continuous deployment that every feature branch is a deployable website. And so it becomes very cheap and easy to sort of just toss URLs around. to each other. So you mean this? What about this? What about this? And so that everyone kind of gets involved in what feels like a pair programming process that goes beyond fingers on keyboards writing lines of code. And so, yes, I'd love to talk more about that.
Yeah, I think it's part of the webinar series. We'll get that spun up, and John's got a great exercise he did with a bunch of the developers and designers here at Think Company. They kind of like displayed how this sort of thing can work. But then, we're not just pairing between developers, we're pairing between designers and developers, which I think is a huge benefit for a team if you're able to get that scenario to happen.
Yeah, I think that was a really exciting experiment that was going on when it was going on. It was very exciting for me to see that developers and designers were, working together and contributing in that sort of like a mob coding approach to that. And I think that we're waiting for the questions to come up. So another question that I scribbled down while you were going through your talk, when you were doing the McCain, the USS McCain example. So imagine a world where a developer had actually noticed that flaw in the software, and did not feel as though they were able to, they felt like they're, they have to stay in their lane. Like what kind of advice would you give someone on, on how to approach something like that, where you see something that could be a dramatic flaw in a piece of software, but they feel like, oh, I'm in a world where developers aren't allowed to really cross our boundaries. How would you encourage them to cross those boundaries?
Right. So in a lot of the teams I have, I'm a big fan of risk registers. This idea that there's a long running collection of things that could be everything from, Timmy has a hangnail to, this boat might crash if we don't fix this problem. Right. And I encourage everybody on the team to add things to that, at will, so that we can sort of like see all of these things and talk about them. Right. And then mitigate the things that we think we can mitigate. And not for nothing, the first risk register I ever had on a project was something I spun up as a relatively junior senior developer. It was a thing I heard about at a conference, and we didn't have those at the company I was working at the time, but I kept seeing problems like that. And so I just started one, and then I shared it with my tech lead, and I shared it with a PM, and then I just kept adding things to it until other people did too, right? It can be frustrating sometimes to see a problem like that and not be able to fix it. But again, I go back to the Revzilla example. There might be cases where there might be a reason that just isn't very easy to see why, we're not going to fix that thing right now. And so, I guess I can kind of see both sides for that. It can be very frustrating as a junior or more junior person in the organization to not be able to just tackle the problems when you see them. But I think it's important to still call them out, and to raise that flag. And in that case, maybe it had happened, and I've seen similar, large, maybe less, life and death situation-y kind of things, but, similar sorts of things brought up all the time on projects where people are able to point out a problem and save us a lot of time and effort later on, or a lot of like heartache in front of users by tackling these things. So yeah, bringing those things up, sprint retros are a great place to do that. The risk register concept, really, it's kind of a hard question to answer because every team kind of handles things a little bit differently, but those would be my suggestions.
Great. Well, we're not getting any questions from the crew, but I think, Mac, I think you may have had some other questions you wanted to throw out to the crowd.
Yeah, I was
for that.
I was curious. I talked a bunch about different things I've seen on projects. I'm curious if there's anyone in the crowd that could share process debts that you've run into. On projects that you've had. I see Ryan Gallagher in the list. We've actually been on projects together, so I can call out some projects where there's been some tech debt there. But I don't know if anybody has anything that they're able to share as far as things that they seem going wrong that they feel like tech debt, but are really more process sort of oriented.
Well, Ryan says he's here. Ryan, if you do you have a thought you want to interject? We can unmute your microphone if you do.
Maybe not. Sorry, Ryan. I was probably going to warn you before I called you out.
Yep.
All right. Fair enough. I just heard the exit sign. I was just curious who we dropped.
Oh, that was one of our panelists, I think.
Oh, cool.
Amanda.
All right. Well, we're at the top of the hour. I mean, if there's no
Yeah.
questions, do we want to just wrap it up?
Sure. All right, let me get my screens in order here and get to the right stuff.
Yeah, I'll drop, we'll send out an email that's got a list of a lot of the references that I've got in here. I'll throw these slides up on the slide share as well. So if you want to like pop through and see any of that. And also, you'll notice I actually dropped 2 sections. I don't know why this took me so much longer to get through today than it did during the practice sessions, but you'll see some additional material in there. I'll try to roll that out in the form of blogs over the course of the next couple of weeks, so that you can see more of what I would have covered in those other 2 sections that I skipped.
Great. Well, thanks for taking the time, Mac, and thanks everyone who attended and signed up. Thanks, John, for answering some ad hoc questions there. Just for a couple of notes, and Suzanne posted these in the chat channel, or in the chat field down below. We will be sending out an email soon with links to everything that Mac referenced in the webinar, along with a link to the recording if you want to share it with anyone. Mac, we'd also like to get some feedback on the webinar. So if you have 2 minutes of spare time over the next few minutes or the next couple of days, and please fill out the webinar at the link there. If you want to get a virtual coffee with Mac, we've been doing this. A few people have signed up for these where they can sit down and just chat about some of the things that they've encountered or ask some questions one-on-one. You can sign up for a virtual coffee with Mac using the link there. And again, if you've enjoyed this session, you want to register for the next webinar that we have with Sean Hickman, Understanding Design Systems. There's a link to that, and you can follow us on social media, or check out the follow-up emails that we're going to be sending out on the seminar for all these links as well. So thank you very much for your time, Mac. Thanks everyone for showing up. I hope you got some value out of this talk. And if you have ideas for other talks, please send them along too. We'd love to hear them. And I think that's about it.
Yeah, thanks everybody.
There's one, what's in chat?
It's just me telling Mac that I've been posting screenshots of your slides into a Slack window while an Agile ceremony is going along, and people are being like, oh my gosh, are you looking over our shoulder? It's like, yes, nailed it. Thank you, Mac.
That's great. Awesome. Thanks, John. And thank you everyone for attending.